Welcome to another program in our series on Free Thinking Forum. I'm Bill Weir, the producer and host, and I'm delighted to have with me a man that I heard speak a few Sundays ago at Science Sunday in DuPage Unitarian Universalist Church in Naperville, Illinois. Scott, welcome to our program.
Thank you very much. I'm absolutely delighted to be here with you today.
Well, I'm delighted with what you presented and the series that you are presenting there. It sounds like something many of our other congregations could try to do as well.
Well, thank you very much.
You're a scientist, aren't you?
So I'm not a professional scientist. I have a degree in physics, but I work in computer science, if you will, currently. But throughout my life, I have maintained an avid interest and a curiosity about science and the way the natural world works. And that has compelled me, I might say, to keep up to date with things ranging from geology to biology to astrophysics, you name it. If it's about the way the natural world works, I'm just right there on the spot trying to learn as much as I can and try to help other people understand it as well.
Good for you. We need that.
Good, thank you.
And I think I heard you describe yourself as a science geek.
Yeah, I think that's a fair term. I rather than describing myself by my profession, my passion is really science and science communication. So science geek fits me about as well as anything.
And, why did the DuPage Unitarian Universalist Church start Science Sundays in the first place?
Well, the fellow who started it, I didn't actually start it, was a gentleman by the name of Mike Winter. Mm-hmm. And Mike is a former educator, and he really likes the idea of teaching other people and talking with other people about educational topics, and he has a particular passion for science as well. So it was his notion to start using the adult education forum portion of the of the Unitarian service time frame to do science education for adults. Although I would stress to say it's not just for adults. We have children that
teenagers come in, children
a fair number, not a huge number. But it was Mike's idea to try to improve scientific literacy among the population there at the church, and it has expanded beyond that to where even people that have no other affiliation with the church per se come to partake in Science Sunday.
Yeah, and I had the impression that perhaps there was an even bigger turnout at the 11 o'clock Science Sunday than there was at the early service.
Right. Yeah, so you happened to be there for a Science Sunday forum that we gave at around 11 o'clock, but typically it runs coincident with the first early morning service. And almost habitually, the attendance at the Science Sunday forum discussion is, or lecture as it were, is higher than the attendance in the formal church service, sometimes by 2 to 1.
Wow. Well, you're doing something very popular then, that we need to learn from.
Well, thank you very much. It seems if people are voting with their feet in some sense, and they seem to like it.
And what is your particular series? I've heard it called Quest, is that right?
Yeah, the Quest series. So it's modeled really on what Carl Sagan and Neil deGrasse Tyson did with the Cosmos series. The way I describe it, it's got a sort of a tagline for the title. It's a wanderer's journey through a wonderful cosmos. And my intention with the series of lectures is to delve a little more deeply into the various topics that we cover than you would typically get in a PBS program or even in the Cosmos series itself. So I try to go a little more in depth while still trying to keep it accessible to a general, intelligent, curious audience.
And I noticed that you're willing to answer questions too. The
Yeah.
television set doesn't do that.
That's true. That's true. I love taking questions. To me, any question is just an example of somebody's mind being engaged and chewing on a particular topic, and I like to see that those wheels turning.
Yes. Well, the wheels were certainly turning when I was there.
Yeah, I think we were talking about.
Both in my mind and lots of other people who asked questions.
I think we were talking about symmetry theories in particle physics that day.
You want to say a little? You want to give them a sample of a symmetry
Oh, sure.
lecture? What would you be saying in Science Sunday?
Well, so one of the things to think about when you think about symmetries is there are any number of examples we could use, but one of them could be water. So any water is formed of molecules that have a particular symmetry in their shape, and yet that water can exhibit itself in many different forms. You wouldn't go ice skating in a steam bath. You wouldn't try to ice climb a pond. You wouldn't try to go swimming in a glacier. So different physical states of water can manifest vastly different physical properties that could keep us from interacting with one form of water while encouraging us to react in a different way to a different form of water. But underneath it all is a symmetric molecule of water that's the same everywhere in the universe and in every ice cube and in every cubic meter of steam or in every cubic meter of seawater, etc. So there's an underlying.
One hydrogen, two oxygen.
You've got it right. Yeah,
Yeah.
You remember well your basic science, and the symmetry of that molecule gives rise to a lot of complex behavior, such that the symmetry itself may be hidden from our view unless we probe it in a very special way. And there are other very similar special symmetries in nature. And very quickly, there was a lady who was a mathematician and a scientist. She was overlooked for the Nobel Prize. Her name was Emmy Noether, and she was active about the same time that Einstein was active. And she discovered that if you have a symmetry in a physical system, there's a corresponding conserved quantity. The simplest, most succinct example of that is because if I do an experiment over there or I do an experiment here, because there's a symmetry of space where I do those experiments, that directly and clearly, even mathematically, implies that momentum is conserved. We've always probably heard about the conservation of momentum. That's a very direct consequence of this symmetry of space. And my lecture talked about other symmetries and some of the conserved quantities that arise because of that.
That's very interesting how she discovered symmetry, but apparently didn't get the recognition that Einstein did.
Yeah, it was endemic at that period of time for women scientists to be overlooked. Marie Curie was the single delightful exception to that, but there were
discovering X-rays.
That's right. Her work on radioactivity. So many female scientists were overlooked by the Nobel Committee unfairly, and hopefully we continue to improve our ability as a society to recognize all people who contribute.
Yes. Now, your particular series, do you have some credentials for this, the physics degree and the work in computer science, but more important, the long-term keeping up with science?
Right. Yeah.
Beyond what most of us do after we get out of high school.
Yeah, it's the passion I display. Before I started this series, I had given some guest lectures to a couple of Unitarian churches, some different churches. I gave a lecture about the meaning of life. Oh. And I've given other talks. I talked about how to build a Death Star and what it would take economically and materially and in terms of energy to actually try to build a Death Star. And those lectures were well received enough that it led to me being offered this role in presenting a whole series of different science topics.
And so the series is basically carried on by, what was the gentleman?
Mike Winter.
And so we can credit him with getting things started?
Yeah, I credit him hopefully every time I see him. So he was very instrumental.
And now, do you only cover science dealing with current cultural concerns like climate change and GMO foods, alternative energy, and so on?
Yeah, that's a great question. So those kinds of concerns are at the forefront in a lot of people's minds because they impact the world, the macroscopic world that we interact with and that we must live in. But I think just even general science literacy can help people develop what I think Carl Sagan termed a baloney detection kit.
Right. We need that.
Right. So I've talked about relativity theory. I talk about particle physics. I talk about things perhaps relatively far removed from our everyday experience, but it can instill a skill for looking for what science has to say about the way nature really works. And sometimes what science has to say about that can be absolutely astonishing and beyond what we might otherwise expect even in science fiction.
That's great.
Yeah, thank you.
And what do you say about climate change nowadays?
Well, so because I'm not a credentialed scientist, one of the things that I maintain, and I try to convey this consistently in my presentation to people, is the very best that I can do is to look at the consensus that has grown among scientists about any given topic. If a particular issue has a lot of divergence of expert opinion, then necessarily my opinion must be divergent. And the best I can do is convey what different sides say about a particular issue. But there are no two sides to climate change.
It's happening.
Absolutely. Scientific consensus is something like 98.9% if you look at journal articles.
And the other 0.1% or 1.2 are maybe paid by the people who don't want climate. Us to know that there's climate change.
It could be, and I suspect in some cases that's exactly what's happening, but it's not necessarily true. You know, one of the things I try to convey is that every scientific truth that we know is provisional.
Yes.
Everything we know about the way the natural world works is subject to reaffirmation and validation. And
so we can't expect the scientists to say it's 100%
right. Yeah, and it causes a problem. There's a vocabulary problem in science to a certain extent, because a scientist will talk about theory, and he means something different than idle speculation.
Oh yes.
Right? When science talks about theory, science is talking typically about something that has been wildly and substantially supported by evidence. And evidence is what distinguishes science from pure speculation.
Both evidence and reasoning.
Well, sure, yeah, reasoning.
And you say wild, but there's some calm reflection that's gone into
right.
that to make sure, yes, this test substantiates that test.
Absolutely. And pure speculation has its role as well. I mean, you look at something like string theory, which is almost nothing except a mathematical and philosophical construct. There's even debates among philosophers of science about whether string theory is a science or is it just a philosophy that happens to have a lot of mathematical trappings. So that gets to something called the demarcation problem in science and the philosophy of science. What constitutes science and what constitutes non-science or nonsense?
Well, science begins with someone formulating a hypothesis that needs to be tested.
Well, that's one way it can begin. It can also begin by observation and categorization. Mm-hmm. Right? You see some animals that fly, you see other animals that swim, you see occasionally an animal that can both swim and fly.
Oh, let's see. What do you call those?
Strange.
Now, I was going to ask you about unicorns and
right.
dragons.
Oh yeah, that's so we had a conversation about that a little bit before taping started. So one of the things, and this gets to a demarcation problem and some of the logical tools that we use to investigate scientific claims. One of the things that you may hear occasionally is that in order to prove there are no such things as unicorns, you would have to look everywhere on the Earth simultaneously, maybe take a picture of it with a giant satellite camera or something, and show that nowhere in that picture does a unicorn evidence itself. And yet, we have a different way as science aficionados of showing that unicorns are highly improbable, if not implausible. Mm-hmm. And that is, if you look at the record of life on Earth as it has evolved over time, you see different characteristics that are exhibited, like 4 limbs, like having a head separated from a trunk, right? That happens in fish, in insects, in nearly every form of life. One of the things we have never seen about a form of life that's a mammal, a unicorn would ostensibly be a mammal, is a single horn coming out of a head. Now,
I thought we saw that in a rhinoceros.
well, that's a great point. So with a rhinoceros, it's not actually bone material like it would be in a hypothetical unicorn. In a rhinoceros, it's the same kind of stuff that makes up hair and fingernails that's matted so tight that it forms a bony or a horny, it's called a horny structure. But it's not an actual horn of bone like is imagined with a unicorn. You can also talk about a narwhal that has a single projecting spike, and that's actually a tooth that has taken on a different aspect. The point is that if you look at both the extant species on Earth and the historic species that we can uncover from the fossil record, you don't find any precedent for having a mammal with a single horn coming out of the middle of its head. So if there are no precedents for that, then we can say with a great deal of confidence that it's highly unlikely, if not practically impossible, that there will be such a creature suddenly in our particular biome at this point in time. Same thing with dragons. A dragon ostensibly has not just 4 limbs, but an extra pair of limbs on the back to make a total of 6. Ever since Tiktaalik and some of the limbed, lobed fishes that have crawled out of the ocean, there is no evidence of something with a spinal cord and a similar kind of structure having 6 limbs. So dragons are an implausibility as well. And science can begin to answer those questions by a combination of clever speculation and insight, as well as the evidence accumulated in the fossil record.
Well, maybe that's why I like to use my walker. I get 6 wheels on the ground, so to speak.
Yeah, that's right. Yeah,
6 legs on the ground.
Well, you know, I think that leads us to another delightful point, that science isn't about just saying, here's what is. You know, unicorns don't exist because nothing has 6 limbs. But by applying what we learn about nature and the way it works, the way balance works, the way gravity works, the way that human locomotion works, the way a wheel works, you put all of these things together, and with the power of the human imagination, we can create constructs that help us improve the qualities of our lives by applying what we learn about the constraints that nature imposes upon us. And we can use those to our betterment. Studying science is the best way forward, improving our economy, improving our personal lives, improving our quality of lives.
One example being people trying to fly.
Well, that's right. For thousands of years, that didn't work so well.
Even though, who was that Greek that tried to fly?
Daedalus and Icarus, I think,
yes,
right?
Yes,
right.
Icarus. And those wings didn't work. Had to move science along farther until we have these airplanes of today.
Well, you know, one of the things about the Daedalus and Icarus story is that it's potentially a cautionary tale about striving and reaching and soaring too high. And in that respect, at least in respect to science, I reject that cautionary tale.
Me too.
You know, I don't think that there is a depth so deep, a crevice so remote, or a height so grand that science shouldn't be applied to understand what's happening there.
So we ought to be able to ask questions.
Any question we like.
And form hypotheses about what might be the right answer.
Right. Sometimes even the questions might embarrass people, but you know, that's okay, because science will tell us what's real and what's plausible rather than maybe what we want to hear.
Now, what do you have to say when someone says, well, science is not all relevant to me. I'm just living an ordinary life. Yes, I'm a Unitarian Universalist, but that's irrelevant.
Right. Well, I certainly understand that point of view. There are many things that can occupy our attention and our minds besides natural science. We can be concerned with economic justice. We can be concerned with well-being of other people around us. But at some point, when you delve deeply enough into those questions, you run up against scientific limits. Right? So one of the things I intend to talk about in some of my future programs is basic economics. And I think no matter what area of study or area of curiosity or area of passion that you have, science at some point comes into play. Even if you're a musician or a painter
definitely.
or a writer,
Yes.
right? You still at some point have to be cognizant of the limits to the tools that you have that
Where each C above the other is vibrating twice as fast. Is that right?
Yeah, yeah, something close to that. I'm not an expert in music mathematical theory, but something like that.
So, why is science knowledge particularly relevant to humanists?
Well, that's a good question too. I think that I would distinguish between humanists and Unitarians. I think often humanism is a subset of Unitarianism, and the specific distinguishing factor there that's relevant in this context is that humanists explicitly reject any appeal to the supernatural. And some humanists still believe in some kind of supernatural agency, whether it's pantheism or some kind of deism, etc. But once you divorce yourself from the idea that there is some supernatural agency to which we can appeal to help understand the world or change the world, the realization hits you that if we want to make the world a better place, and insofar as that is possible, it really behooves us to figure it out and to come up with solutions. And that, to me, is the big appeal of humanism, is that it takes this starting point, which is there's nobody to rescue us but us. And from there it says, you know what, given that that's true, what's the best we can do? And the best we can do is to use science to figure out what's plausible, possible, and real.
Good. And a lot of folks need to know more science about their health, for example.
Absolutely.
In order to remain healthy.
Right.
And be on the team with their doctor and other healthcare specialists.
Yeah, I think with regarding healthcare and physicians and whatnot, there's this idea of skepticism. I have one friend who says anytime I see a doctor, the doctor tells me something and that's what I do. I have another friend who says when I see a doctor, I'm going to look up every result myself and I'm going to check what other people are saying about this condition or this result. And I think the latter person displays a level of skepticism about medicine that says, I don't just take it for granted that a given medical practitioner knows everything. On the other hand, you can go too far with that skepticism and start second guessing every diagnosis or every conclusion. So again, we get back to the idea of consensus. What does the science say about what's going on with your body? What's the scientific consensus? What's the medical consensus? And skepticism divorced from evidence is just as poisonous as other flights of fancy.
Earlier today, I was in the library looking up, and I came across an article by a couple of MDs who were saying that we need to switch the perspective of medical doctors from simply finding diseases to cure, instead focus on wellness.
Right.
And have you spoken about that yet?
No, I haven't spoken about any topics directly related to medical practice yet, and I'm not sure that that's going to fall within the purview of my series. But
perhaps there are others who will speak on that.
Yeah, perhaps so. Somebody else who comes to Mike Winter's Science Sunday.
Yeah, and you've already mentioned some surprising science facts that you've covered in your series. What are there others that you could mention?
Oh, sure. Let's see. One of the more interesting science facts that we covered this year was this notion of where does gold come from? In fact, that was the subtitle of one of my science lectures.
It comes from the ground, doesn't it?
Good first approximation. Good first approximation. So we don't have time to trace the whole chain of causal events back arbitrarily far, but to give you the Cliff Notes version, it's there's a pretty compelling case to be made that all of the gold that we find on planet Earth, and in fact, perhaps all of the gold that's available in the universe, was generated by events where two neutron stars crash into each other.
Really?
Yeah. So not just a star that blows up in a supernova or some other chemical
But
or
two
nucleosynthesis.
neutron
Stars
collide.
Right. That seems like it's consistent with the rarity of gold in the universe and some of the nucleosynthesis processes that must occur in order for gold to be synthesized.
So we're not going to have any more gold on Earth.
Well, if we do, by virtue of some nearby colliding neutron stars, that probably wouldn't end.
It might arrive in a meteor.
Well, it might arrive in a burst of gamma rays that would fry every living thing on Earth, which would not be...
no thanks.
Yeah, right. So we're going to have to make do with the gold we have, I think.
Yeah. Now, I've also heard that about helium, that we can't make any more helium.
Well,
is that true?
Yes and no. So there are some radioactive decay processes that happen naturally in the Earth that give rise to helium. So helium is essentially a couple of protons and a couple of neutrons, and that helium, what's called the helium nucleus, can be ejected by certain naturally radioactive processes. So a small amount of helium accumulates in the Earth, locked in the Earth over time. The problem with helium is, as you know, it's really light and it floats, right? It'll rise up. It'll rise up in our atmosphere of mostly nitrogen. And it turns out that the gravity of Earth is too weak to be able to keep helium. I might have said hydrogen, but same applies to hydrogen and helium. The gravity of our Earth is too weak to keep helium locked in from our gravitational field.
And it only has one proton and one neutron.
That's hydrogen. Yeah, hydrogen has one proton. Helium has two.
And two.
Right, yeah, two and two. And by the way, you're talking about surprising science facts. Another surprising science fact is that Mars will never have a rich atmosphere of oxygen and nitrogen. So all these...
and that's what's in the air we breathe.
Right, that's necessary for life. And the reason that's not going to happen in Mars is because Mars' gravity is so weak that it can't even hold on to oxygen and nitrogen.
Really?
Right, Mars is a much smaller planet and its gravity is weaker.
Well, I'll cancel my real estate deal on Mars then.
Good call.
So, what have you planned for the future, Scott?
Well, I'm thinking that perhaps next year or the year following, I want to do a series on something called the Drake equation. And,
what's that?
Well, the Drake equation is something that was devised back in the, I believe, 1960s. And the notion is I want to project or predict how many, or what the likelihood is of a certain number of intelligent, communicating, advanced, sentient, or intelligent species. You might call them aliens. That's the common term for them. So how many aliens are out there?
Planets.
Yeah, how many aliens are on other planets? And it turns out that when you start analyzing that question scientifically, you start to have to consider things like, what's the possibility that life would arise on a planet? What's the possibility that liquid water would be on a planet? Another surprising science fact. You often hear people saying like, well, maybe it's not life like we know it. It turns out that carbon is one of the most ubiquitous elements in the universe.
Oh.
So is oxygen. And carbon is a very gregarious molecule. Carbon will bond with nearly anything, including itself.
Yeah, carbon dioxide is,
right.
That's got 2 oxygen and 1 carbon.
Methane has 4 hydrogens and 1 carbon.
Yeah. So, well, thank you for tuning in. We'll hope to continue this another time.
All right. Thank you very much. It's been delightful.